Welcome to the new Cyber Frontier, bringing you the latest news on the local Colorado economy and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host, Chris Gorog, brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. Chris is personable and opens up with our guests on the issues we all would like to see addressed. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
So welcome to today's episode of New Cyber Frontier. Today on with me I have Bernard, and Bernard, you're going to have to help me with your last name. It was very difficult to pronounce here.
So it's Bernard Harguindeguy.
Okay, and he is the CEO of Elastic Beam. Now they have some really interesting technology coming out, and he's going to tell you about that release. But Bernard, wow, 35 years in the country, 30 years in startups, several startups, and I was impressed when you told me that the Chrome browser was your startup that you had then sold to Google, along with all the IP and everything and the team and everything, which still works there. So that's a great credentialization to see where Bernard has been and his new company Elastic Beam he's really excited about. So Bernard, welcome. How you doing?
Thank you, Chris. Very good.
Good. So give us the 30 seconds on what you're doing with Elastic Beam.
Well, we're focused on the security of API beyond the traditional just access control. And one of the things I've done back 3 years ago, I reconnected with a good friend of mine who was one of the technical founders of RPG that Google also recently purchased. And we spent the whole summer brainstorming on how we could really make the API more secure. And the result of that was the formation of Elastic Beam.
Okay, so that is what kind of thing do you sell? Do you sell a product or a service, a software, a package, something they install? What is it that you're selling here?
Yeah, we sell a software package that an organization will buy, and they can install it under their own control, on-premise, in a public cloud, and using any of the tools that people fancy today, containers, virtual, bare metal. So it's always under the control of the customer because it's security, and we make extensive use of artificial intelligence because everything we do is at very large scale. I'll give you an example. We are capable of looking at several 100,000 simultaneous API connections, and we're looking for a needle in a haystack there. Any one of them could be used by a hacker to get to data or systems that are exposed via the API. So that's kind of the key things we do.
Okay, so help me understand, which company would buy this software? Is it a development company that has 100 developers making code and they're actually releasing a product? Is that who would buy your software?
Not necessarily. I mean, it all starts with, honestly, how do people make use of APIs and what are APIs, right? So an API is an application programming interface. It's a very fancy name for a defined way to connect to a set of data or applications. And so the world moved to API-based interfaces that are standard. REST and WebSocket are the key standards today. And they use them because it makes it easier to expose how to use a code. Now, the APIs can be used by an internal team. This could be a hospital. It could be a bank. Give you an example. You could have a team who's in charge of all of the patient records in a hospital. And yet you have another team that may be in charge of billing and payment tracking for those patients. So they will go normally to the team that owns the database and say, hey, I need to access the database. How do I do that? So forth. In the old days, it would have taken many meetings, lots of interaction, things painful. These days, the team would simply define an API, give a quick description through documentation, and make that available to all the people in the hospital so that anyone that needs patient record data could access it. So in this case, the API would be given to the invoicing team, and they will just write their application to just get the data they need when they need it. They don't have to talk to people, they just use the API. And the same, it would be true for a bank, for example, in terms of customer account data and so forth. So this is an example of an internal team. And that team, the API value is faster development cycle, faster product internally and so forth. But that's not the only use of APIs, Chris. You have recent example of big API clouds as a service. Twilio is Stripe, a good example of that, where any number of developers could make use of, say, Stripe credit card payment services by just calling up the API. So they don't have to build this into their own application. And so that's when people talk about monetizing APIs or the API economy, they think a lot about those kind of services. Twilio is similar, but for communication. So you want to build an SMS service inside your own application, don't know anything about communication, that's okay. Just call up the Twilio API, and it's going to do that for you. So that's an example of an internal team helping other developers design, develop, get new applications faster together. That's an example of an API cloud that lets you use their services, but for money. You call the API and you pay based on the use of the API. And you have a third scenario where it's maybe a big retailer that would make available access to their inventory database to their suppliers. So now it's inside an external developer. So I might be supplying a paper product to a big retailer. I can use their API to check the inventory, so I will know when I'm likely to have to resupply those guys, and I can get ready for it. A quick example. So
okay.
That's a typical, I would say, thing in a traditional enterprise.
Okay, well, let's take a break real quick and hear from our sponsors. We'll be right back in a second.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
All right, welcome back, and we're still talking to Bernard from Elastic Beam, the CEO of Elastic Beam. He was talking about APIs and gave some. I had asked him to explain exactly what that was, and I think I understand a little bit better now because I've heard API used in many different terms. I've been in software development for years, but we're talking about here the interface between business functionality. So different parts within your company or services you offer outside the company where people are coming in for a service. So instead of talking to like a person and getting customer service, they'll be able to go through this API to get the data themselves. That's what I'm understanding that you're talking about here, right?
That's right, Chris.
Okay. So now I know we had talked earlier that there was a lot in security and things that we needed to focus on to secure this because, I mean, literally, if you open up an interface for people to get data and they don't have to talk to a person, they can just sit there and hit that all the time and you know, you really have to think hard about how and who you give the information to and when do you allow them to have information. So tell us about, you know, more about what these APIs are doing and how security kind of plugs into what you're doing there.
Yeah, Chris. So fundamentally, you hit the key issue with the APIs, right? On one hand, they give you great economic value, faster time to develop stuff, external access, and so forth, and they front end literally everything these days, data, system. I'm even thinking control system in the Internet of Things world, a line of business application. And so you have initiative, for example, today, like the European Union initiative, which is forcing the banks to open their APIs so that the fintech industry could participate in providing services to their customers. And so APIs have become the linchpin of everything connected to the internet. And I think that it was David Berlin who not too long ago was saying API security is fundamental to the security of the entire internet. Why? Because today an API will give you access to data, to an application and so forth, mean everything. Yet today, the only way you control the access is through user name and password. In this case, it's API name, API password. You typically also would supply a signature, depending on the implementation, and many times not even. You would think that people will always force this to be super secure, but it's never super secure. Hackers are quite good these days at defeating access control systems. They steal tokens, they steal passwords, they brute force attack the login system, and they get in. And so what do you do to go beyond that? You need to do two things at that point, right? You need to try to detect what's happening, so you need to track every access, you need to be able to audit them, you need to be able to report on them, and you need to try to understand whether something illegitimate happened during an access, which is not always really easy. So security is really about tracking what happens after someone logs into the system. And yet, there are many possibilities to break into, but the teams today, and I don't know how to put this in a super nice way, when teams develop APIs, those DevOps teams never believe that security is their job. They believe that they are paid to develop an API, and the API will be developed. Security is not their job. So whose job is it? The job now internally is usually the job of an IT security team. But unless you design security from the get-go into the architecture of the API and the services, you will never truly achieve optimum security. And I think today that's kind of where we are. From a how do we go forward from an industry point of view? I think it's about giving a DevOps team more visibility into all the bad things that can happen to the API and how it will happen, and educate them so that fundamentally the design of the API takes security into account. And then, of course, better tools, better processes, and better educated IT security team to train them on what to look for. And so that's, I think, what the industry has to do over the next, starting now, over the next several years, to truly secure an API infrastructure.
So is it possible, I mean, thinking that the API is an external interface, is it possible to take and put some kind of a wrapper on top of it? So an API interface on top of every API interface that does some kind of a security functionality. Is it possible to do that, or does it have to be wrapped and designed into the existing, infrastructure and structure more in an integrated fashion?
Yeah, no, it has to be the later. It has to be designing. People have to understand, I would say, good hacking techniques, which usually today, Chris, it's really amazing that. Well, let me take you. A good friend of mine was a CTO of a very large company was telling me, Bernard, he said, once someone logs into one of our APIs, we just don't know what's going on anymore. We don't know. And so you need obviously to prevent people from logging to an API if they're not supposed to log onto that API. So that's the access control. And then you need to train the team and you need to have the tools to really track every access and understand these accesses and understand if any one of them could be an attack or a breach. It's interesting to know that there are a lot of industry reports these days that all point out to the same problem. The average time it takes to detect an attack, a breach, a data set is 2 to 3 months. That's the average. And in 6 months. And usually it's discovered through an audit that was not even planned. It's accidental. And then you realize, whoa, look what happened. And so training the teams on being more careful during the design so that it's not so easy to breach an API, but also training the team on how to track the use of the API. And obviously doing this at scale is not easy. And so you need good tools to do that at the end of the day.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Over 3 million data breaches happen every single day. That's over 2,000 records being compromised every minute. So often, we focus on securing web data access. But what if the attackers are already inside, having gained direct access to your storage through data management software? When it comes to communications that go directly into your storage devices, make SNIA your first line of protection. SNIA's conformance testing limits outdated communications that are known to be used by attackers. It works continuously behind the background to make sure your storage is protected. To find out if your data is truly secure, visit our website at www.snia.org/cybertest.
And I'm hearing that this is a multi-phased approach. Kind of like with network security, we have to build a baseline. So we got to start monitoring first, understand some trends, understand how users are using it, understand how they're getting around things, understand how they're misusing it, and then go from there into our development environments and feed that information back to our developers to know what to do for the next generation. Is that what I'm hearing?
Yeah, in a way that's right? So there's a lot of new initiatives happening, right? For example, we start to work with Keen-Lane, who I'm sure doesn't need an introduction for most of you, to define the criteria for rating API security. We're also working with a couple of large organizations on security standards for PSD2, which is the new European Union Open Banking Initiative. So defining standards, defining processes, training, teaching, coaching teams is all part of what we need to do in order to protect APIs. The scary thing, right, in all of this, in a way, is that APIs bring great economic value. I mean, the future is a future of just APIs. However, they do represent an incredible attack surface for hackers. And the professional organizations who literally make a living these days out of hacking, stealing data, compromising systems. So big attack surface will require great attention. And it's just starting. People have not really done that, so it's not built into the fabric of those teams yet.
Okay, so if a company has an API that they have for people getting data, and they just don't know what type of usage patterns, usage trends, how would they start this process of understanding and monitoring? I think that's what you're telling me your Elastic Beam product does. But talk to us about the process of getting this started and off the ground.
Yeah, so let's say that your APIs is used with a flow of traffic that's not too high, right? Reasonable. Maybe it's 10 queries per second or 5 queries per second. Then a lot of this can be literally, I would say, tracked almost manually, right, to really check things. The biggest issue, obviously, is access control, right? If someone managed to steal a token, and there are many examples of that in the past, right? The IRS was hacked. You all heard of the Apple issues with celebrity pictures being taken, or I would say a manufacturer of a car whose control was taken over remotely through an API. All this is usually access control defeated by the hacker or token stolen by a hacker now impersonating a valid user. So that's what happens. So at small scale, you can still try to manually look at this, but it very quickly becomes a big data problem. If you're looking at 1,000 transactions per second or query per second, you're 10,000, 5,000, 100,000, and no one can do this. It has now become a big data problem. And the only way to really tackle big data problem is with machine learning and artificial intelligence, so that you can sort it all out and provide really good reporting on everything that happens. And if you suspect maybe that a cookie, a token, an IP address is responsible for something, you can now quickly write a report or deliver a report that shows you everything that this IP address or token or cookie did. And either feel good about it because it's all normal, or worry about it because now you saw things that were just not normal, systems that were touched that were not supposed to be touched. So that's the kind of thing that we focused on. We use AI to sort out everything. We look for that needle in a haystack, and we detect cyber attack, pre-login, post-login. The access looks normal. The behavior looks normal initially, and suddenly it is not normal anymore. It could be an insider, it could be a botnet, it could be a hacker. So now data is being accessed, data is being manipulated, a system is being taken over. We detect those with artificial intelligence, and then we can report it, but we can also do something about it. We can terminate the attack automatically as well. So fundamentally, we focus on two things: recognizing a cyber attack pre or post login, recognizing who is responsible, terminating the attack automatically, reporting it as well. And for people who now need to know, okay, I just detected that this happened, and I want to know what else did this guy do on my system and what system did he touch, we can now run a report for you and show you everything that was touched, not touched, and every action that was taken, down to every method or command used by the hacker. So that's kind of what we focused on. But the key is to do this at, I would say, the multi-cloud scale, and to work in hybrid environments. So we have customers who have 3-4 clouds: the public cloud, private cloud, AWS, Azure, Oracle, private cloud, and we are able to recognize attacks across clouds. We're able to communicate the attack to other clouds so they can terminate or prevent reconnection. It's a scale that makes these things really difficult for most teams, and that's what we focused on, Chris.
Okay, so if I were to adopt and start this process of looking, even using your software to start analyzing, getting trends, is this something that's turnkey, that when you put it in, boom, you have immediate stats, you know, and you can start blocking things right away? Or is there a timeline that you have to spend a year or so, or I don't know, more, building up the baseline before you really become effective?
With our software, and I have to credit Uday Subarayan with my partner in all of this, and he was one of the technical founders of RPG. Uday and I, from the beginning, wanted something that was self-learning, that would auto-configure itself, that will literally deliver all of this functionality within a few hours of being installed and deployed. And that's what we achieved. Today, you can install the system, and within a few hours, you can have a system that will report right away anyway. Within the next minute, it will start reporting on all accesses and give you complete in-depth details of everything going on with your APIs. And then within a few hours, we start pointing out for you any attack that may be detected. And with AI, we don't do the traditional thing that people do. We don't give you probabilities. We tell you this is an attack. We're sure it cannot be a false positive. This is an attack. Or we tell you this is an anomaly. It's probably not an attack, but you need to look into it. Or we tell you it's all normal. So obviously we spent 3 years developing this platform. We're in our third generation on the AI engine, and that's why we were able to get there. But from a deployment point of view, there's very little you need to do. You just need to give in a JSON format an API definition file. That's all you need to do. And even that will go away. We've been working with several API gateway vendors, and the result of this collaboration will make our software totally self-configured with no configuration to do. You launch it, you give it an IP address, and you're done. That's it. So from a deployment point of view, it could be a container, it could be a virtual machine, it could be in AWS, it could be in an Oracle cloud, it could be in Azure. It doesn't matter to us. You can have your own data center and you have AWS or own data center and an Oracle cloud, and everything will talk to each other. It is that simple. Simplicity comes at an enormous cost of big effort, lots of work. Simplicity, as you know, takes more time. But I think that Woody and I achieved that. We have a great team that we built, a team of data scientists, a team of API experts, a team of security experts, and it took a good team working together to achieve what we achieved.
Okay. Now you had mentioned that you do trends analysis, store data, analyze big, kind of a big data with AI. What about the persistence of data? Is this something that you use a database? Do you store API usage and information about one API in like an information sharing environment where it goes between multiple clients? How does your utilization and persistence of these large amounts of data and trending information, how is it utilized, and who has access and visibility to it?
So we use a MongoDB database today, but you could substitute that with any other database if you needed to. We use MongoDB database. It can be deployed in a single node or in a master-slave node, primary, secondary node. The machine learning or AI engines themselves are clusters. They use APIs themselves, so we make extensive use of APIs ourselves. So to write a report and access the database, you would use one of our APIs, and we supply multiple sample reports built with Postman that one could use right off the bat, right? And make right away use the API to get to the database through our AI engine and start reporting on it. We also make available a really nice dashboard that was built on top of Kibana that also use APIs to get to the AI engine and the database. And we start giving you minute by minute, second by second updates on attacks being detected, errors generated on APIs. We did auto-discover all the URLs on an API. You see all the URLs attached to that one API. We'll give you a top view of all the APIs and so forth. So from a security point of view, the system does a lot of real-time security and a lot of artificial intelligence security. Together, we look for essentially 3 bucket type of attack. Pre-login attack, someone is trying to defeat your API. Post-login attack, I mentioned before, data theft, data deletion, data manipulation, account takeover, so forth. And we also have multiple types of denial of service attacks on the APIs. Now, I wanted to bring this up, Chris, because we see more and more of our customers subjected to denial of service attack on APIs. These are usually not, and most often not, caught by traditional DDoS techniques because they are not volumetric attacks. They are not about sending a massive amount of something to take down a service. You don't need a big payload to take down a cookie management service or to take down a token management service. You need very few data. So the payloads are small, and they will never be detected by a traditional DDoS system. And that's what we've seen with our customers who literally were under great amount of pain, even large amount of money on big DDoS hardware, software systems, still not stopping this. So we stopped multiple DDoS attack on the APIs. We stopped post-login attack. We stopped pre-login attack. And you can see all of that through a dashboard or through the reports.
Okay. So, and I didn't quite catch, do you use multiple clients' data to make these decisions and in the engine for one client? So if I would get this on my API, am I going to get shared information and threats from other clients that you have using the same software?
It's a really good question, Chris. So the first part of the question is, with our artificial intelligence engine, we look at every connection on an API for all the APIs, from all of the clients. So you can have one client accessing multiple APIs, you can have multiple clients accessing one API, and obviously multiple clients accessing multiple API over time. Our algorithm cover all of those different cases. It's a very complex set of algorithms, as you might imagine, to really look for the needle in a haystack. But once we detect an attack, what we report stays with the customer. We've had customer asking if we could share attack information from detected in other customer environments. We haven't done that yet, but we're likely to make that available as an opt-in service in the near future. What that would mean is that if we detect, let's say, a bunch of attacks on a bank, and the bank may use big cloud, they may be all obviously private, maybe not, but mostly private these days. The attack information itself, right, that would be who attacked it, what was the attack like, where did the attack come from. We could share this attack information with our other bank customer or with hospital and so forth, so that they could be on the lookout for those attacks and our system could block them immediately. We haven't done that yet, but we've been asked a lot about it, so we're likely to do this in a near real time, but in an opt-in fashion. So that will allow people to be better prepared, as you might imagine, for an attack that has already been experienced by someone else, and make them better prepared to defend against it.
All right.
The other thing too there, Chris, is when you know you are the only one being attacked and no one else is being attacked the way you are, then you tend to defend yourself in a different way, right? Because now you know you're not one of many, you are the only one. And you may at that point decide to put all of your IT resources on the problem to do whatever it takes to defend yourself. So that's another valuable piece of information we can provide our customers.
Yeah. Okay, well, we're kind of getting to time. I wanted to wrap it up, but I wanted to give you the opportunity to tell our listeners, who are your customers, who can contact you, how would they get a hold of you, and what markets are you providing your products in?
So we have customers in a few verticals. The Internet of Things vertical, industrial customers, they monitor machine sensors and so forth. We have customers in the defense industry, the federal business in the U.S. We have customers in the banking and healthcare industries. And then we have what we call big cloud services customers. So these tend to be B2B or B2C. The volume of transaction is huge. The services are available in publicly available clouds, so you just go on the internet and you can sign up. These are about the key verticals where we've seen a lot of traction. Banking is big, obviously, because of the security issues. And the key in all of these is, as I was saying, is that we can end up, and we've been working with Skinline with some of these end up defining the criteria for defining API security, and a lot of those criteria may be tied to some of those verticals.
All right. Well, thanks for joining, and we definitely are interested to see how your Elastic Beam company works out, and how you grow over the years here. And we'll definitely be interested in keeping up with you. Thanks a lot today, Bernard.
Thank you very much, Chris. And I forgot to tell your audience that to get to our website, if they have any question and want to reach us, go to elasticbeam.com, and you can just contact us through the website. And we look forward to following up with you later, Chris. Thank you very much for the opportunity.
All right. Thanks a lot. Have a great day. The views or opinions expressed by me during this podcast are my own and are not those of my employer, Colorado Technical University.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.